Hey kids, do you ever have this problem? Worry not kids, we're here today to show you how to solve this.
In this video, I'm going to show you how I went from this to this. When a notification pops up while you're playing the mega fun obby, you must solve this partial derivative to receive your Robux. Follow along.
Hi everyone, today we're going to learn about how to take partial derivatives. And the partial derivatives are used when a function has more than one variable, and instead of finding how the function changes with respect to all variables at once, we're just going to focus on one variable at a time while treating the others as constants. So we have this function here, x squared y cubed plus 3xy, and we're going to first find f of x, where we take the partial derivative with respect to x, and that means we're going to treat y as the constant. So the first term, x squared y cubed, we're going to keep y cubed as the constant, and we're going to take the derivative of x squared. So this is going to give us 2x times y cubed. Now for the second term, we're going to do the same thing. We're going to take y as a constant and take the derivative of x, which is 1. So we're going to have the second term be 3y. Now for f of y, we're going to do the same process here, where we take the partial derivative with respect to y, and this time we're going to treat x as the constant. So x squared y cubed, here x is a constant, so the derivative of y cubed is 3y squared. So we're going to write. And for the second term, 3xy, x is the constant, so we're going to take the derivative of y, which is 1, and this gives us 3x for f of y.
Okay, so if you have fx, the way that you'll solve fxy is by taking the derivative of fx with respect to y. So you get 6xy squared plus 3. Yay! Very easy. Now, what do fx, fy, and fxy give you? So if fxy, let that equal profit, then we're going to say x is price, y is advertising. So fx is going to be how your profit changes when you change your advertising. fxy is going to be, and this is a little bit wordy, but how the effect of price changes when advertising changes. So then if fxy is positive, it means that raising prices works better when advertising is higher. And if fxy is negative, it means raising prices works worse when advertising is higher. So it tells you if two factors amplify or weaken each other. Yay! 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 Hooray! Good job.
Partial derivatives can be used to help us find heat flow across a given space. Given the first law energy balance shown in blue, which is a fancy way of saying that energy isn't created or destroyed in a process, and that mass is equal to density times volume, this can be used to show the equation in pink, where we need to note that T is equal to T of xt, where the partial derivative is taken with respect to T. This is only relevant to show the heat flow along the x-axis written as the equation in blue, where K is thermal conductivity. In the limit where delta x approaches 0, we can write the equation in red. This is Fourier's law of heat conduction. We can combine this law with a Taylor series that shows heat flow across differential length. This creates a general one-dimension conduction equation, where longitudinal conduction plus internal heat creates thermal inertia. All of this is fancy chemistry calculus ways of saying how heat flow works. Essentially, what the partial derivative is helping us find in Fourier's law is not the flow across a given segment, but rather how much flow fails to reach the following point. That is the value that's changing across the shape. Thus, partial derivatives are extremely helpful in determining maximum temperatures in a reaction, or the amount of volume required to create insulation in housing. Let's take that second example and look at the partial derivative in Fourier's law, which measures the rate of temperature with respect to position. That's what's vital in creating architectural concepts such as padding. The partial derivative may indicate where insulation is required. This is how we can use partial derivatives in real-life applications.
By the way, partial derivatives are used in math to find slopes of tangent lines and planes on multivariable functions. They also locate maximum and minimum values in optimization problems. They solve partial differential equations like heat and wave equations, and they create linear approximations of curved surfaces.
Now that you solved your partial derivative, get your free Robux. Look how rich we are. Yay! Yay! Hooray! Yay! If this helped you, make sure to share. Thank you. Yeah.